Let us continue our discussion on this language. We said the set of all strings satisfying this condition where number of zeros and number of ones they don't match. This can be constructed using two sub languages. L1 says number of zeros is more and L2 says number of ones is more. And so we are done with the discussion on L1. We looked at the base strings are 0, 0, 0 and then 0, 0, 1, 0, 1, 0, 1, 0, 0. Then we asked how do we generate other strings, say strings of this type or an arbitrary strings of this type or a string of length 4 using this as the base string. And then we did couple of investigation and then we found out that the pattern will be like this. So this can be generalized, and we were discussing that this 0 can be replaced with 0, 0 or this can be replaced with 0, 1, 0 or 1, 0, 0. And then the larger message is we should bring non-terminal so that this replacement can take place. And towards that end, in that direction, we concluded that this is how the CFG will be. Now, if you carefully look at this, with this you can pump any number of zeros satisfying this condition. And if you introduce a 1, then 1 can come in three forms. So all three are captured. And with 1, the other two side could be AA. Now you can look at it this way. Let's look at 1AA. Now if you supply 0 for A, 0 for this A, then it becomes 1, 0, 0. Or you may replace this with maybe some pattern from this, maybe same pattern, say 1 AA followed by this A. Now you see that at any point in time, in the first iteration it is 1, 1, 2 A's, second iteration it is 2 1's and 3 A's. So the number of A's is at least one more than number of 1's. And how are we going to replace A at a later iteration? We are going to replace A with zeros. Now you can see that if you bring all zeros, then it is 1130, or you can have any number of zeros because it only says strictly more, correct? So which means this can be replaced with 110A. This may be 0A followed by A. Either you replace this by just 0 or by 0A, and now you can see that number of zeros is more, number of ones is less. But at any time you see that number of A's is at least one more than number of ones. And that's precisely what we guarantee through this grammar. And you start with say A1A. Now you have decided to replace this using AA1. Now you see that 2 1's, 3 A's. You have decided to replace this with 1AA, so you get this. Now you see that 3 1's and 4 A's. Now A can be replaced by just a 0 or sequence of zeros using this. Fine. Now this was our initial thought, an arbitrary string of this, how do we generate? Now you can see that this can be generated using 0A. To start with, it will be 0A, and then again it will be 0 followed by A, and then choose the one appropriate with respect to this substring. So I choose 1 AA, and now what will happen? This becomes 1 AA, The next one is 1, which means again I choose 1 AA followed by A. Fine. Now this one is 0, so replace this by 0. This one is 1, so for this you choose 1 AA followed by A. So like this, by looking at the first symbol in the substring, you can choose whether to go for this or whether to go for this, and so on. Fine. So this way we can generate any arbitrary string satisfying this. Most importantly, the base pattern we identify that can be generalized to bring in any kind of strings of this type. Fine. So having seen this, now this would be relatively straightforward. Let's construct this, and then we just have to combine these two to answer this question. Okay. The similar line, let's try attempting this. Here number of 1's is more, which means one can pump just a 1 or 1B. With this you can pump any number of this. So the base strings are 1, 1, 1. Then if you go for a 3 length, this number of 1's is more. So which means it could be 1, 1, 0 or something like this, or it could be something like this. So number of 1's is 2 and 0's is exactly 1. Now with this can we generate other strings. So B implies now you want to introduce 0 and between 1's. So it could be 0BB or B0B or BB0. Now at any point in time you see that suppose you start with B implies 0BB as part of parsing. Now you replace this with some pattern, say B0B and followed by this. You see that the number of B's is at least one more than number of 0's. And at a later point in time, you can replace B with this or by 1B. So that way you will have more 1's at any point in time. Fine. So which means this one is L1, this one is L2. It says B implies 1 or 1B, or B implies 0BB, B0B or BB0. Fine. Now an arbitrary string in L can come from this or this, because when it is not matching, it will either satisfy this condition or this condition. So how do we construct L? S implies A or B. Then you write whatever we have written. A implies 0 or 0A or 1AA or A1A or AA1. And B implies 1 or 1B or 0BB or B0B or BB0. Fine. So now this clearly tells you an arbitrary string can come from this or this, and we know how to generate the one that is satisfying the first condition, satisfying the second condition. You just have to combine this. Now this clearly tells you if L1 as CFG and L2 as CFG, then L equals L1 union L2 as CFG. Equivalently, If this has push down automaton, if this has push down automaton, then even this has push down automaton. Fine. So this clearly tells you the operation union is closed. Closed in the sense that you choose two languages which are context free or for which PDA exists, then the union also has a CFG, a context free grammar, or also as a push down automaton. It has a push down automaton equivalently, meaning if you find CFG, you can find PDA. If you find PDA, you can find CFG. Those constructions we formally see, but they are all equivalent. Fine. So, and the other message is a language like this, if you try attempting to construct context free grammar, it may be not that easy or it may not be that elegant as this. So often one has to look at the question carefully and look at sub languages, look at subsets, and then try constructing for each of them and take the union. Fine. So the other interesting question on the similar line is what about intersection, concatenation, clean A star? Fine. All that we shall explore now.